Hello Year 11, welcome back to our second video here for further graphs. In our first exercise there we looked at reciprocal functions and we're going to apply some similar principles to square root functions. Okay, graphing square root functions. So again, mostly from a sketch. There are some important things to notice. That, right, I can't take the square root of a negative number. So if my original function is negative anywhere, any part of the domain, the range that is negative, right, there will be the square root will be undefined, right? It just won't exist there. So we can only do that. The square root of 0 is 0, the square root of 1 is 1. That's going to be helpful to us as well for those intersections, a bit like the reciprocal of 1 is 1. So that's all fine. What else do we have here? If my original function is between 0 and 1, I could say less than 1 because we're not going to look at anything less than 0. But if my original function is between 0 and 1, the square root of, let's call that a small number, square root of a small number is bigger than that small number. Right? If I take the square root of a quarter, I get half, right, which is bigger than a quarter. But if my function is greater than 1, then the square root will be smaller. Rightio? I think we're just about ready. You can read through some of those things if you like. Here we go. We have another very straightforward linear function, y equals x plus 1. And there it is. That's y equals x plus 1. No, it's not. That's y equals x minus 1. And I want to sketch the square root of y equals x minus 1. I think we've got a typo here. Change your notes there so that says x minus 1. Otherwise, it's really not very helpful if I draw y equals x plus 1. So looking at this, my function is negative anywhere where x is less than 1. So x is less than 1, this function is undefined. Of course, we can see that. So I have that there. Between when my function is equal to 1, then the square root is also equal to 1. Right, that's helpful. And so between 0 and 1, my square root function should be greater than my original function. But after that, then it's going to be less. Now, y equals the square root of a linear function of x is going to be like a parabola on its side. So we get, there's an important point, right? Now that's a closed circle because this can be equal to 0. I can take the square root of 0. So at x equals 1, I get 1 minus 1 is 0. The square root of 0 is 0. That's fine. Right, you can see it passes through, right, that point there where my function is equal to 1. They're both equal to 1 at that point. Right, and then it continues along slower than my original function. Okay, here's another one. Again, I don't have the equation of this, but you can see my function is negative from negative 1 to 0. So my square root is undefined there. And for any value of x greater than 1, my function is undefined. So my domain for this square root will be x is less than or equal to negative 1 and x is between 0 and 1 and equal to those. So those are critical points there where my function is 0, the square root is 0, so I've put some dots there and they're closed dots because it is equal at that point. Now, over here, because my function is greater than 0 but less than 1, my square root is above the function there, right? It's above that because when I take the square root of a small number, right, where I'm defining a small number between 0 and 1, that square root is greater than the small number. Now for this little section over here, right, it will be greater until I get to 1, right? It should cross over there and then move away slowly again, or at least slower. Rightio, so something like not that. Again, not the most smooth curves in the world, but they're okay for a sketch. Rightio, I haven't plotted them in Desmos or something. They've just been drawn using whatever tools I had available here in PowerPoint. Righto, square roots. One more. We have the sine function again. So, again, because my range is from 1 to negative 1, my square root function From 0 to 180, that's fine. From 180 to 360, we know that's third and fourth quadrants, and sine is negative in the third and fourth quadrants. So I can't take the square root of that. So it's only going to exist from here to here. And again, recurring as this periodic cycle repeats itself, or this periodic function repeats itself. So the zeros are still equal to 0, and my function will sit slightly above that. Okay, slightly above sine x. The square root of sine x will always be more than sine x where it exists. Righto. That's basically it for square roots. A little note here, if you have something that says y squared is the function of x, it's not quite the same as y is the square root of function x, because it could be plus or minus. Now the plus is the bit above, the minus is the bit below, so you draw the bit above and then you reflect it again underneath the x-axis. Rightio, but that of course would not be a function. It's going to be a relation. I'm going to use those words, function, but that's how you deal with the y squared equals function x. If you've got a y squared, not y equals the square root, then you have the positive part, and that's reflected to make the negative part. Okay, that's kind of it. Graphing the square root of a function. Keep in mind, square root only exists where the original function is positive. Okay, so there might well be some serious restrictions on the domain. The square root will intersect the original function where they're both equal to 1 or to 0. Okay, the square root of 1 is 1, square root of 0 is 0. Those are the only two numbers where that's true. Okay, and between 0 and 1, so here we go, the square root will be greater than the original function. That's it. If you've got any questions, please jot them down, let me know. Otherwise, I'll see you for our next video, which is absolute value graphs. Okay, thanks to year 11. See you then.